Topic 4, hazardous chemicals and ld50. This is topic 4 in your science focus textbook. So looking at pollution versus a pollutant. A pollutant is any material or form of energy that will cause harm to a living organism. This can be physical, chemical, or biological. Pollution is any alteration of the environment, producing a condition that is harmful to living things. How much is too much? So we use concentration to measure the amounts of substance present. A solute is the substance being studied, for instance, DDT. The solution is where it is being studied, aka the body of a fish or a volume of water. Concentration is a representation of the amount of solute by the amount of solution. And how we measure these amounts gives us different units of concentration. One that we're going to look at here is parts per million. Parts per million, what we're going to do is we're going to have the mass or volume of solute, and we're going to divide by the mass or volume of solution. Then, to represent it as a part per million, we multiply by 1 million. What we do here is the mass need to be in the same unit. So we could use grams and grams, or we could use kilograms and kilograms. They just have to be the same. We can also use units of volume like milliliters and milliliters, or liters and liters. Again, they just need to be the same unit for both the solute and solution. So an example here. A 230 kilogram bluefin tuna contains about 145 milligrams of mercury. What is the concentration of mercury in the tuna in parts per million? What you should know is a milligram is 1,000th of a gram, and a gram is 1,000th of a kilogram. So 1,000 milligrams equals 1 gram, and 1,000 grams equals 1 kilogram. I'm going to use that information and I'll convert these units for you. In any other question, I would have given you units that are probably the same. All right, so 145 milligrams, 145 milligrams. I multiply 1,000 milligrams over 1 gram, or under 1 gram. So I'm dividing by 1,000 and I get 0.145 grams of mercury. The 230 kilogram bluefin, there's 1 kilogram in 1,000 grams. So we're multiplying by 1,000 and we get 230,000 grams is how much that bluefin tuna weighs. So to calculate the parts per million, we're going to use the mass of the mercury divided by the mass of the tuna fish itself times 10 to the 6. So 0.145 grams of mercury divided by 230,000 grams of tuna times 1 million. What I end up with for a concentration, or parts per million, is 0.630 parts per million. So small. Toxicity is the ability of a chemical to cause harm to an organism. Acute toxicity is a serious symptom after one exposure. So for instance, cyanide, botulism, anthrax, fentanyl, one exposure can be fatal. Chronic toxicity, on the other hand, symptoms appear only after the chemical accumulates after many exposures over time, like DDT or mercury, lead. So a bunch of those, we need to have multiple exposures and it stays within our body and builds up over time. Minamata disease was mercury poisoning, I do believe in Japan, where people were being poisoned by a factory and they didn't know what it was. Feel free to YouTube it if you'd like. There are a few videos. I just didn't think that it was something we really needed to study in great depth. ld50. So it's difficult to establish the level at which a substance is toxic due to different body masses, our different metabolisms, lifestyles, and the different types of organisms. ld50 is a useful guide to ensure proper safety precautions are taken when handling certain substances. ld50, is the dose of a chemical that will kill 50% of the population to which it is applied. It's usually measured in parts per million, and typically it's been experimented on mice or rats, and ld50 is reported in that way. The ld50 for some substances are here. So we can see, for instance, nicotine from cigarette smoke. For people, approximately 0.86 parts per million would kill 50% of a sample of people. The least toxic would be this dieldrin. It takes 80 parts per million to kill 50% of the population, whereas botulism, toxin A, it only takes 0.0000003 parts per million to kill 50% of a population. So it doesn't take very much, where it takes a lot more of this dieldrin. So, knowing this, government agencies take strict precautions before approving new drugs because everyone responds differently. A dose that kills one may be only discomforting to another, and toxicity depends on the amount of chemical ingested or absorbed. We can't rely on published toxicity levels to determine the effect on humans if it wasn't studied on humans. Of course, we wouldn't want to have a study where we're looking at how much will kill you. Nobody would ever sign up to participate in that study. So we use our information from mice and rats typically to inform what would happen to humans. Every chemical has the potential to be harmful, depending on the dose, the person's susceptibility, and how it reacts with other chemicals that person may be taking. We need to, when we approve something, they want to know that the benefits outweigh any possible hazards. So, for instance, thalidomide was used in the 1960s to reduce nausea in pregnant women. This resulted in thousands of babies being born without limbs or having extremely short limbs. This thalidomide, only a small dose, so 0.05 parts per million, was able to produce babies with birth defects. So, did the benefits outweigh the risks? Being not feeling sick versus having a baby born with birth defects. Obviously, the government was like, whoa, what's happening? And they banned the use of thalidomide for pregnant women. Because obviously the risks were great. For practice, don't forget to complete the learning guide for this topic. And there's some extra practice in your textbook if you want to take a look at those questions.